What's popping? My name is John and welcome to John Physics. Today I'm going to be demonstrating a physics concept for my project-based assessment for a Professor Danilo Tadeo of YIS. I'm going to be demonstrating the siphon. Now originally I was going to do one of these kinds of siphons, the kind you make at home, and a good demonstration of vacuum. Now the problem with that is, there's no way I'm going to get a good grade for just making a normal siphon, but I'll demonstrate to you how a basic siphon works anyway. Now, the way it works is, you see this cup is full of water. Do you see? Now, if you want to drain water from a body of liquid, such as this cup, but with a constant rate of flow, measured usually in liters per hour, it would be best using a siphon. And in this way, now the way a siphon works, is, well, when you suck water, it causes a vacuum to form, and thus hydrostatic pressure inside of the straw pulls the water out against the force of gravity, causing water to pour, and it'll keep pouring at an ever decreasing rate of flow that will eventually reach the height of the water in the cup. So as the water's height is at the tip of this straw, when this flow point matches the point at which the cup's fill line is here, it'll stop flowing. Now, that's interesting enough on its own. You can use that to drain a pool of water slowly and effectively, but the problem with that is it takes suction force. As you can see, I sucked the straw in order to get this flow going, and that's highly inefficient. It takes a whole manner of pumps in order to get the kind of force that you'd need to drain a lake full of innocent ducks, for example. So, what I came up with is the kind of siphon that starts automatically when it reaches a certain kind of height. This is called a bell siphon. It's commonly used in urinals and hydroponic water vegetation systems, and it's a very interesting idea. So it has the same concept of being based on a vacuum of air causing water to flow downwards. But here I have a large bucket of water, and unfortunately I constructed it before shooting the video, so I'll just show you how I made it. So I have this large plastic clear bucket, and I have a straw in here. The straw has been drilled in with a seal over it, and I have this cap also with a hole drilled into it that contains this apparatus. This was formerly my toothbrush holder, but now it is a highly sophisticated mechanism of physics. This is a tube sealed at the top with holes at the bottom. This is nothing, this is just to get the water in. Now, what happens is, you put the cap on. Oh, I broke it. Okay, so as I broke it a second ago, I've restarted it. I fixed it a bit, and now I'll show you. You can barely see that the water is just above, or just below the straw. It's just peeking above the surface. Now what'll happen is, when you pour the water in just a bit, it'll start a vacuum. You see that? There's a bit of a whirlpool forming up there. And it'll cause the water to start flowing when I pour in just a little bit more. It'll flow at a constant speed from up here. Now you can see the whirlpool. And it'll flow at a constant rate, measured in liters per hour. I haven't measured this one in particular. It was a bit too hard to get that kind of measurement, but it will keep flowing until the vacuum is stopped. So I'll get a good angle here. And when the water level kind of hits that entry point, the flow will kind of halt. So as soon as air gets sucked in instead of water, the vacuum will be broken and the flow will stop. That's it's very epic. It took me a good few hours to make that one. But yes, this can be used in such applications such as hydroponics. That is the kind of growing of plants using only a bed of water and gravel. And how it's used is you want to have a constant flow of water to keep the vegetables or plants hydrated. But you don't want to drown them, causing mold or any kind of algae to grow in the pool. So you want it to all drain out at certain intervals. So what you do is you'd have a pump of water pouring into a large pool, but then you'd have a bell siphon at the bottom so the pool doesn't overflow or retain water for far too long at far too high capacity. So at measurable intervals, usually a few hours, the pool will fill up and the water will drain out, restarting the cycle. The other use is for automatic urinals. You ever walk up to a urinal and wave your hand in front of that black thing causing the water to flow? It flows so quickly and knows when to stop only because of the bell siphon. Now, you might think that's extremely inefficient, but because it is electrically triggered, it is far more inefficient to have a motor or a valve that's electrically handled. So what they do is they have water filling in and halting at a certain level. And when the electrical signal is triggered, a small pulse of water is added, which causes the full cycle of flushing, therefore allowing for a much more efficient energy usage in automatic urinals. Now, it took quite a bit to make this, a lot of glue, a lot of plastic, and I guess I'll give a full list of materials so I can meet the requirements. 2 large plastic tubs. This is my dog's food plastic tub. Now, I also used a lot of wood glue, and it's probably not the best method but it works. And you just take some scissors, you cut a hole, and you just make sure you get a seal. There has to be a perfect or near perfect vacuum of water at the top, because the only way it works, the only way water can seemingly defy gravity, is if the force of pressure inside of this chamber up here, is greater than the force of gravity. And when it's greater, it'll start sucking water in to try and balance out the pressure with atmospheric pressure. Thus, we have the bell siphon. It took quite a bit to make it, but it is worth it. I'll have my own automatic urinal system running in no time. Comparing this to a normal siphon, you can kind of see the drawbacks of a normal siphon, but a normal siphon has more use applications when the amount of water in a body doesn't exactly matter, and you can drain with a normal siphon in any direction. Anyways, thank you guys for watching. I hope you enjoyed another episode of John Physics. I've been your host, John, and I swear I'll post videos soon. Goodbye.